Welcome back, everyone. Today, we are going to explore the derivative of the tangent function, y equals tangent of x, from first principles. Let's break down the math step by step. We start with our baseline function, y equals tangent of x, which we will call equation 1. Next, let's introduce small increments to our variables. If x changes by a small amount, delta x, then y will shift by a corresponding small change, delta y. This gives us our second equation. Y plus delta y equals tangent of x plus delta x. Now let's subtract equation 1 from equation 2 to isolate our change in y, giving us delta y equals tangent of x plus delta x minus tangent of x. Next, we rewrite the tangent functions in terms of sine and cosine. Finding a common denominator allows us to combine these fractions into a single expression. Look closely at the numerator. It perfectly matches the standard identity for sine of a minus b. Simplifying the terms reduces the entire numerator beautifully to just sine of delta x. To establish our rate of change, we divide both sides by delta x. Now, let's take the limit as delta x approaches 0 on both sides. We separate the limits to isolate our fundamental limit fraction, sine of delta x over delta x. Evaluating the limits, our special sign limit evaluates directly to 1. As delta x goes to 0 in the cosine term, the denominator becomes cosine of x times cosine of x, which is cosine squared x. Since 1 over cosine squared x equals secant squared x, we reach our final proof. The derivative of tangent of x with respect to x is exactly secant squared x. Thank you so much for watching. If this step-by-step proof made finding derivatives from first principles clear, please make sure to like, subscribe, and share. See you next time.